This is part 2 of the iterative functions. So in the first video, we left off right here, graphing points versus age. And what we should immediately realize here is that at 21 points of age and 24 points of age, that X input has 2 different ages or outputs that go with it. So where is that? 21 happens here and here, and 23 happens here and here. That goes directly against the definition of a function, which is that every input is paired with exactly 1 output. So this input of 21 is going to 2 different outputs. 23 has 2 different outputs. So in this case, what you should notice is that this is like the quick way to tell if a table is a function. Your X values cannot repeat. If they repeat, it means an X is going to more than one Y, and that immediately means it's a relation, but not a function. So let's actually make sure we remember that. This is a relation. This one is a function. What you should note here is also, in the first one, we saw that Y values can repeat. So let's look at that table again up here. I had 21, 21, and 23, 23. That's okay if the Y repeats. You can repeat Y as much as you want, as long as an input goes to only one output. So you could have an input, you could have just one output with many different inputs, but you cannot be repeating your inputs and having an input go to many different outputs. So what we would say here is, because you're going to want to be able to verbalize this, instead of saying Y is not a function of X, what we would say here is that age, which is our Y, is not a function of points per game, X. Y is not a function of X. Age is not a function of points per game, and that means that age does not depend on the points he's getting. Points per game. So Y does not depend on X. Age does not depend on points per game. Make sure you actually think about that and process that, because next week you'll be doing this in context with different scenarios, and you'll have to be able to think this way and talk in terms of the situation here. So that is with the table. So always look to see if any inputs are repeating or not. That will be your immediately telltale sign. Now let's do verbally with a real situation, real life situation, I should say. And what we can use with a real life situation, or really in any type of function representation, is something called a mapping diagram. So mapping diagrams help you visualize the situation. So let's do 1 or 2 situations together here. And I'll show you how we can use a mapping diagram if you want. You don't have to. Oops. So we're going to let our first variable R. Now we're going to use different variables than X and Y because this is in context. So R is going to represent residents of my hometown and the best city in the USA, Pittsburgh, Pennsylvania, who have telephone service. Telephone service. Any kind of telephone service. We're going to let the second variable T represent telephone numbers. Any kind of telephone numbers. So T is all the telephone numbers of the residents in Pittsburgh, Pennsylvania. Now we want to decide, is this a function or not? So what we can do here, if you're having trouble thinking about whether this would be a function or not, is a mapping diagram. You're going to have 2, sometimes they're boxes, sometimes they're circles. The first box is going to represent your inputs. Oh my God, inputs. And in this case, our inputs are the residents. Our outputs are the telephone numbers. So we don't have actual numbers here. Like sometimes you'll have actual numbers in your mapping diagram. I'm just going to put dots here to represent residents. Doesn't matter how many you put, just put them in here. And I'm going to have my outputs represented like this. So just throw some dots in here, doesn't matter where you put them. And what you want to think is, if I have a random input here, so these are residents. Does every resident have a telephone number? And does every resident have only one telephone number? Because remember, to be a function, every input can only go to one output. So now you want to think here, think about actual people here. Do they only have one telephone number associated with them? And if you think about that for a minute, you should come to the conclusion that people can have more than one telephone number associated with them. Like this person here could have a cell phone, they could have a work phone, and as archaic as it might sound now, they might have a home phone. So this one input has 3 different outputs. That means they're not a function. It's a relation, but not a function. You might still have people who don't have a telephone number. That's very rare, but we might exclude some people. So this is definitely not a function because you can have people with more than one telephone number. And you can jot the reasoning down if you want. I'm just going to put not a function right now. And instead, it is a relation. So I'm going to set the next one up with you, and then I'm going to give you some to do on your own. If you want to do a mapping diagram, you can. So we're going to let our first variable C represent citizens of the United States. Let the second variable S represent the Social Security numbers of citizens of the United States. So if I'm going to do a mapping diagram, I have my citizens and my Social Security numbers. So here are some sample citizens, and here are some sample Social Security numbers. So you want to think, does every citizen have only one Social Security number? Is it possible for one citizen to get mapped to a second Social Security number? So take a minute and think about that. And if you think about it long enough, you should be thinking again legally here. Legally, every citizen should only have one Social Security number. So that definitely makes this thing a function. So here are the rest of them. I'm going to have you do these on your own, and we'll go over them whenever I see you again. So we're going to have a relation connecting student to his or her eye color. Is this relation a function or not? The relation connecting each student to his or her final grade in a single class. So maybe we have a final grade in Algebra 2. Is that relation connecting a student to their final grade in the class, is that a function? Next, let's let the first variable R, again we're doing residents of Pittsburgh, Pennsylvania. This time we're doing pets. Let the second variable P represent registered pets in Pittsburgh. Next, we're going to do the relation assigning students in your school to his or her biological mother. Biological. And then for the last one, you're going to reverse the above mapping. So instead of students to their mother, you're going to have mother to students. So if you want to draw a diagram, sure. If you don't want to and you think you can visualize it on your own, that's fine as well. You should have some kind of reasoning for each. So to end the video, when you get to class next time, I want you to compare these answers in a group. And if there's any discrepancies, you can discuss those and come to a final answer. These are going to help you do colored slips in your groups. And there's going to be another video on domain and range coming up, and then there'll be a half sheet associated with that. And then when I come back, we should be all caught up and on track again. So make sure you have all this written down, make sure it's taped, and yeah, the next video will be domain and range. See you later.